Okay, here we are wrapping things up as far as probability is concerned, but actually as far as our whole class is concerned, since this is our last topic. Uh, what we have talked about so far is just the general concept of probability, the idea that you calculate probability using a fraction, and this is always the same fraction. We've also talked about different methods for calculating the numbers that go into that fraction. So fundamental counting principle, permutations, combinations, things like that. What we're going to do in this video is not really present any new material. We're just going to talk about a general approach that might help you with these types of problems. One of the issues that some students have with these problems is because all of them are word problems, they're all story problems. Sometimes students aren't quite sure, how do I sort through the information? Where do I start? What do I do? What are key things that I need to decide as I approach these problems? And that's the purpose of this video. So in this video, we're just going to outline a basic idea or a basic process that you can follow. It's not a process that you must use. Think of this as just some helpful suggestions. In the following video, which will be, by the way, the following video will be the last video of our class. In the following video, I'll use this process to work through a couple of the examples. All right, so with that said, let's turn to our learning objectives and start things moving on our last lesson. Here we go. We're going to develop a strategy for solving problems that involve counting and probability. Develop a strategy for solving probability problems and counting problems. Okay, now, because of the fact that we're still working with problems, this hasn't changed, right? These are problems and we've worked with problems all year long. There are some universals that still apply. Remember, many, many months ago, we learned a 5-step process for approaching problems, okay? 5-step process for solving problems. And these steps are the same today. That's not going to change. 5 steps for solving problems. Number 1, you need to understand the problem. And understand, so that means understand the information they give you, but also understand what the question is. You have to understand it. Number 2 is you have to organize the data they've given you. So whatever information they've given you in the problem, you need to sort through. What are things that I need to know? What are things that are irrelevant? This is one of the tricky ones in probability problems because some of the important information, some of the important data is actually not numbers. And you'll see what I mean when we get into this. Once you've organized your data, you develop a plan. And then you carry the plan out. And when you're done, you check your answer. And remember, when we say check your answer, really what we mean is just ask yourself the question, does my answer make sense? Does my answer seem reasonable? If I have a question about probability, we know that the biggest probability you can ever have is 100%. And since we write our probabilities as decimals, 100% is equal to 1, right? So the biggest probability I can ever have is 1. So if I solve a problem and I end up with a probability of 8 or 8 million, something's wrong there, okay? By the same token, if I'm working with a question that asks me to calculate the number of ways that I could do something, and I end up with an answer that's a decimal, well, that doesn't make any sense. How can you have a half of a way or a quarter of a way? Either it's a way to do it or it's not a way to do it. You can't have decimals. So in this type of problem, checking your answer is really just asking a question, does my answer make sense based on the question they asked? Now, specific to problem solving with probability and counting, what we're going to focus on mostly is this step and this step, okay? Which means I am assuming that you're going to start by taking time to understand the story. So whatever they're describing in the problem, you've got to start by taking time to understand that. And you have to make sure that you understand the question. You've got to make sure you understand that. Now, specific to this particular unit, there's really only 2 questions that they're going to ask. The only questions that they're going to ask are either find the number of ways to do something. Okay, it might not even be number of ways. It might be like find the number of license plates, find the number of lottery tickets, find the number of different ways that you can win a contest, whatever. Find the number of ways of doing something, or it's going to say find the probability. Find the probability. Okay, so those are the only two questions we're going to be asked in this unit. There's no other questions for them to ask. They're going to ask us to count, find the number of something, or they're going to ask us to find probability, find the probability of something. Those are the only two things. Okay, now I'm going to jump ahead just a little bit to part of the plan for just a second. I know that's getting ahead. The plan isn't until step 3. But if they ask for probability, if they're asking us for probability, then part of our plan has to be to use the fraction that we learned in the beginning of our unit, that probability will always be equal to the number of desired outcomes, or desirable outcomes, I think is how we said it, divided by the number, the total number of outcomes. All possible outcomes, whether they're desirable or not desirable, doesn't matter. Good, bad, ugly, everything goes in the bottom. Number of desired outcomes goes in the top. All right. So that, as far as my plan goes, if they ask me for probability, this has to be part of my plan. Okay. If they ask me to find counting, to find the number of ways to do something, if they ask me to count, then this will never be part of my plan. So even though developing the plan comes later, and we are going to talk about that, this is only one piece of the plan. There's going to be other parts of it. So we're going to develop the plan later after we've organized our information. But once I understand what the question is, I will instantly know whether this thing will be part of my plan or not. Okay. So that's just the beginning part. We start by understanding. The next step is organizing. Okay, so there's our step 1, understanding. Our next step is organizing. Okay, now when we organize information, the way there's two obvious things that we need. One thing when we organize information is we need to keep track of the numbers they've given us, and that's obvious. So I'm just going to say, like always, find the numbers they've given you. And I'm going to say specifically, find the important numbers. Okay. And the reason why I say important is because we know a lot of times we see problems where they give us numbers that are not important. Like, for example, one of the questions we've seen in this unit had to do with runners running the 100-meter dash. Well, if I'm trying to calculate a probability, the fact that the race is 100 meters long is irrelevant. I'm not going to use the number 100 anywhere in my problem. Okay. So that's not an important number to the problem. What's important are things like how many runners are running, how many runners finish, when the runners finish, how many of them get medals, that kind of stuff. Those are the things that are important to me. The fact that it's 100 meters is irrelevant. But here's the part that's unique. We're going to ask ourselves some questions. And based on the answers to these questions, this is going to be how we develop our plan. Okay, this is going to be how we're developing our plan. All right, so the first question we've already sort of established is we need to know whether or not we're using probability. Okay, if we're doing probability, so this is going back to our plan for a second. So if we're doing probability, we need to ask these questions for both the top and the bottom of our fraction. The top is the desirable outcomes. And the bottom is the total number of outcomes. okay? In other words, I guess I'm going to say this in a more explicit way. When I say we're going to ask all these questions about both the top of our fraction and the bottom of the fraction, in other words, we treat the top and bottom of the probability fraction as two separate counting problems. Okay, we have to make sure that we understand the method you use to count the number of desirable outcomes will often be different than the method you use to count the number of total outcomes. Okay, we treat them like two separate problems. So really what I'm about to go through with these questions are questions that will help us develop a plan for how to calculate the number of outcomes. In the top of our fraction, the number of desirable outcomes. In the bottom of our fraction, the number of total outcomes. Or if it's not a probability question, then just simply the number of outcomes that they asked us about. When they say, how many ways can you do whatever? These questions will help us develop the plan of how to find the answer to that question. Okay, so step 2, we're going to ask questions, and these questions will help us to organize the information that's not numbers. Question number 1. Are there multiple events that always occur? Okay. Are there multiple events that always occur? So remember, we learned early on when we were studying fundamental counting principle that if you run into a situation where they use words like this or that, if that's a phrase that they use, how many ways can you do this or do that? That's a situation where I've got two events, this and that, but they're not both happening. It's either this one or it's that one. It's not necessarily both of them. So if there are multiple events that are not both happening, are there multiple events that always occur? If the answer is no, then I have to literally count the outcomes. Okay, we haven't learned a method in our class for dealing with problems that have an or in them. Okay, so we're not going to worry about that. If they use the word or, then we're just going to literally go back to trying to imagine all the different possible things that could happen and then literally count them. Okay, now, if the answer is yes, then we're going to keep asking questions. And here's the next question. Okay, here's the next question. Are there multiple events that are always occurring? If the answer is no, then we're going to literally count. If the answer is yes, then we're going to keep asking questions. Here's our next question. The next question is, are there replacements in the problem? And remember, this word replacements doesn't necessarily literally mean that I'm putting something back. That's not literally mean what it means, although it could be, right? If it's a situation where I'm picking cards out of a deck of cards, if I'm allowed to pick the card, look at it, and then put it back out in the deck, shuffle it up, and end up picking the exact same card again, that's a situation where there's replacements. But it might literally, or there might be replacements where you're not literally putting something back. We saw a problem in this unit about making license plates. And it said, hey, when you put a character on the license plate, the only rule is that, well, there aren't any rules. You just have to have 6 characters. That's the only rule. Get 6 of them. So it was possible to have like A. That could be your license plate. So even though we're not literally putting the A back into the pot, because of the fact that we can choose A more than once, then there are replacements. And we've only learned one counting technique that I can use replacements with. So if the answer is yes, we have to use the fundamental counting principle. That's the only technique that we've learned that will handle situations where things get picked and can potentially get picked again later on. So if that's the situation, we use fundamental counting principle. But if the answer is no, then we keep asking questions. And that brings us then to our third question. Does the order matter? Does the order matter? Okay, so we've talked about sometimes the order matters to us. For example, if I'm talking about racers finishing a race, first place is different than second place. So if Johnny gets first place and Timmy gets second place, that's a different result than if Timmy got first place and Johnny got second place. So in that case, the order does matter. But if I'm just talking about, hey, I'm passing out cheeseburgers to people, and I gave a cheeseburger to Timmy and I gave a cheeseburger to Johnny, that would be the exact same result as if I gave the cheeseburger to Johnny and then I gave it to Timmy. There's no difference there. They both got cheeseburgers either way. So that's a situation where order does not matter. So that's what we're talking about with this question. Do I care about the order? If the answer is yes, if the order is important, then I'm going to use a permutation. And if the answer is no, that the order is not important, then I'm going to use a combination. Okay, and then that's it. So notice this is part of my organizing data information, but I'm not organizing numerical data. I'm organizing data based on the nature of the problem. Are there multiple events? Okay, whatever. Now, I do want to add one other comment that I should have set up here before and I didn't. So hopefully you've got a little bit of room on this first question. Are there multiple events that always occur? If the answer is no, then we have to literally count. If the answer is yes, we're going to keep asking questions. But also, if the answer is yes, we need to make sure we understand what are the events. We need to make sure we know what the events are. Okay, so for example, the license plate problem. An event is when I pick a number and I put it onto my license plate. So if my license plate requires me to have 6 numbers on it, then I will have a total of 6 events every time I pick a number and put it on my license plate. If we're talking about people finishing a race, the event is when somebody finishes. And so if I'm allowed to have 8 people run my race and they're going to finish, then I've got a total of 8 events. Every time somebody finishes, that's an event. Okay. So you need to make sure you understand what the events are, because when you use fundamental counting principle, if you use fundamental counting principle, your problem is going to be set up around those events. And so it is important that you make sure you figure that out. Okay, so there we go. Notice that when I organize my information here, it also spits out the plan that I'm going to use. So this is kind of like a combination of step 2 and step 3. All right, so I'm going through that. Now, once I've got my information organized, I know what plan I'm using. Then I start plugging numbers into the different equations depending on which plan I'm using. I go back and I use the equation that's associated with that plan. And I type everything in my calculator and I'm done. All right. So this is, I guess we'll call this step 2 and step 3, develop a plan. Okay. Step 2 and step 3, develop a plan. There's how we're going to do that. So that is my basic strategies for solving problems. I take time to make sure I thoroughly understand the problem. In particular, I take time to make sure I know if I'm talking about probability or just simply counting. Then I go ahead and I find all the numbers and make sure I identify which numbers are important, which numbers are not important. And finally, I begin asking myself questions. What's happening here? What's happening there? The answers to the questions tell me which plan to follow. And now that I've got my numbers and I've got my plan, then I start putting them together based on the way that particular technique works. All right, so that's it for this video. As I said, I am going to make one more video, the last video of our class for the entire year, a video where I'm going to use this strategy to help me solve a couple problems. So that would be an example video. Thanks for watching this one. Have a good one.